Hello friends, welcome to engineering tutorial. So we'll continue our discussion on thermodynamics. So in this video we are going to discuss about heat capacity, specific heat, and also about molar specific heat and water equivalent. Okay, so let's get started. So what is heat capacity? Okay, so the basic definition of heat capacity is that it is the amount of heat energy which is needed to raise the temperature of a particular sample of substance by 1 degree Celsius. Okay, to increase the temperature of an object by 1 degree Celsius, how much heat energy is required? Heat energy per 1 degree or 1 degree Celsius or 1 degree Kelvin. For that much rise, how much heat is required? Okay, so for degree Celsius, the heat energy is in calories. For Kelvin, the heat energy is in joules. This is the CGS unit, this is the SI unit. So let's say we supply heat delta Q to a object, okay, and that heat energy, it produces a change in temperature of delta T. Okay, unit, just forget about units. Delta Q heat produces a change in temperature of delta T. Okay, this much. So heat capacity is simply the ratio of the heat energy supplied to the change in temperature or increase in temperature. So this gives us the heat energy per unit rise in temperature. Okay, so if it is in CGS, this will be in calories and this will be in degree Celsius. If it is SI, then this will be in joule and this will be in Kelvin. Okay, so this is the unit, CGS unit, calorie per degree Celsius and joule per Kelvin. So let us say we give a heat of delta Q equals to 4 calories to an object, okay, and it produces an increase in temperature by let's say just for demonstration purposes 2 degree Celsius. So heat capacity will be heat supplied by rise in temperature, that is 4 calorie by 2 degree Celsius. This is 2 calorie per degree Celsius. It means for every 1 degree Celsius increase in temperature, we have to supply 2 calories of heat energy. Okay, so if we supply 2 calories, the temperature will increase by 1 degree Celsius. If we supply 4 calories, the temperature will increase by 2 degrees Celsius, and so on. Same can be done with SI also. If we substitute it with joule, this will be Kelvin. This will become 2 joule per Kelvin. Okay, this. So if we supply 2 joules, there will be an increase in temperature by 1 Kelvin. If we supply 4, it will be 2. If we supply 6, it will be 3, like that. Okay, so this is the concept of heat capacity. Heat supplied to an object of any mass. Here, that is the important thing. The object can be of any mass. So that produces a unit rise in temperature, whether it is expressed in degree Celsius or Kelvin. For degree Celsius, the heat energy will be in terms of calories, and for Kelvin, it will be in joules. Okay, the important thing is that the heat raises the temperature by 1 degree, and we want to determine how much heat energy it takes per degree rise in temperature. Okay, that is heat capacity. Next is specific heat. Okay, so specific heat of a substance, it is the amount of heat energy required to raise the temperature of unit mass of substance. That's why I mentioned here, for heat capacity the object can be of any given mass, because mass also comes into play. So specific heat is the amount of heat energy required to raise the temperature of a unit mass of the substance or unit mass of the object through 1 degree. Okay, so here the expression is something like this. Let's say heat energy delta Q is transferred to a mass m of a substance, and that produces a change in temperature in that object of mass m by delta T. Then the specific heat of the substance is given by, so it is written in this way, actually it is C is equal to heat per unit mass, then again by temperature, this. So this gives us delta Q, you can write it in this way or this way, delta Q by m delta T. Okay, this. And we know delta Q, let me use a different ink, okay, delta Q by delta T is equal to heat capacity. This is equal to heat capacity. It is expressed in capital C. Specific heat, it is expressed in small c, lowercase c. So specific heat is heat capacity per unit mass. Okay, this. So delta Q by delta T is heat capacity. So specific heat is equal to, let me write it here, specific heat is equal to heat capacity by mass. This is the definition of specific heat in terms of heat capacity. Okay, this. And the unit, as you can see, it will involve energy, mass and temperature. For CGS it is calorie for heat per gram per degree Celsius. And for SI, the heat energy is expressed in joules, mass in terms of kgs and temperature in terms of Kelvin. So joule per kg per Kelvin. Okay, so if you want to understand the concept of specific heat, it is heat supplied to an object of unit mass, that is 1 gram or 1 kg, that produces a change in temperature, that is increase in temperature by 1 degree Celsius or 1 Kelvin. Okay, this. So let's say if we try to understand it, let's say we supply a heat of, if we supply a heat of let's say 32 joules to an object of mass 2 kgs, okay, 2 kgs, and that produces a change in temperature by, let's say 4 Kelvin. Okay, so this is heat, this is mass, and this is increase in temperature or rise in temperature. So by definition, specific heat is equal to delta Q by m into delta T. So this is equal to 32 by mass, which is equal to 2, and delta T is equal to 4. So that is equal to how much? 4 into 2, 8. 4. So 4 joule per kg per Kelvin. So we have to supply 4, I mean here according to this situation we have to supply 4 joule of heat energy per unit mass, that is 1 kg, to produce an increase in temperature of 1 Kelvin. Okay, for 1 kg we have to supply 4 joules to produce a rise in temperature and increase in temperature by 1 Kelvin. This is the specific heat of the substance. And if this is an SI, if you want to express it in CGS, just replace joule with calories, kg with gram, and Kelvin with degree Celsius. Okay, so this is the concept of specific heat, and specific heat is heat capacity per unit mass. Okay, that. Then we have what? Molar specific heat. Okay, so as the name suggests, here the concept of moles come into play, defined by Avogadro's number. So molar specific heat is defined as the amount of heat energy required to raise the temperature of 1 mole of the substance through 1 degree. Okay, so here if we say we supply heat energy delta Q to raise the temperature of n moles of a substance through delta T, then the molar specific heat is given by delta Q by n into delta T. So actually it is written as first heat energy per unit mole, that is delta Q by n, then that whole thing is again divided by delta T, so that gives us delta Q by n delta T. Okay, and the unit is calorie per mole per degree Celsius, which is CGS, or joule per mole per Kelvin, which is SI. Okay, so molar specific heat is simply the amount of heat Q which raises the temperature of 1 mole of a substance through 1 degree. Okay, this. So let's say here, let's say we have 16 calories of heat energy is given to, let's say, 4 moles of a substance, and that raises the temperature by 2 degree Celsius. Okay, this much. So here the molar specific heat will be equal to delta Q by n delta T. So here, as you can see, this is delta Q, means the heat energy which is supplied, this is the number of moles, and this is the rise in temperature. So that would be equal to 16 by n, which is equal to 4, and delta T, which is equal to 2, that is equal to 2 calories per mole per degree Celsius. So here in this situation we have to supply 2 calories of energy, heat energy, per mole, okay, to 1 mole of that substance, okay, to 1 mole of that substance, to produce a rise in temperature by 1 degree Celsius. Okay, this is the concept of molar specific heat. Okay, then comes the concept of water equivalent. Okay, so just try to understand this because it can be a bit tricky. So basically what water equivalent is, it is the mass of water, okay, it is the mass of water which requires the same amount of heat as is required by any given body which is under observation, which is, which we are testing for the same rise of temperature, which means that in both the mass of water and the given object or substance or sample, the rise of temperature should be the same. Okay, so that is the main condition, water equivalent. Let us say, what it's trying to say is that here we have an unknown sample, a given sample. So here delta Q, amount of heat, produces a rise in temperature by delta T. Okay, this. So we have to find a equivalent mass of water. Okay, equivalent mass of water in which if we supply the same amount of heat, okay, delta Q, it will produce the same rise in temperature, which means in both the cases amount of heat is the same and amount of rise in temperature is the same. But here we have to find the mass of water which is the equivalent of this sample or object or substance, whatever it is. So that is called as the water equivalent of this sample. This mass of water is called as the water equivalent of this sample. So it is given by mass into specific heat of that sample. Okay, mass into specific heat of that sample. That is called as the water equivalent. Okay, so it can be in terms of grams if we are considering CGS, that is calorie and degree Celsius, and kgs if we are considering SI, that is joule and Kelvin. Okay, so this is the concept of water equivalent. So friends, here we have discussed about specific heat, heat capacity, molar specific heat, and the concept of water equivalent. So I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to engineering, science and technology. Have a great day. Thank you very much.